As you can see, the collet chuck is lever operated. So what we need is some kind of anchor point using that hole. This is the annular ring which the clamp faces up against. The last operation on the screw is to cut the screwdriver slot. Burr that. So that's part of the assembly finished. Welcome back to Workshop Friend. Today, something different which has a bit of a story behind it. Some time ago I produced a video on the Colchester Student taper turning attachment, and that video attracted quite a number of views. Well, certainly for me. And several people asked for details of the taper turning attachment because they had parts missing. One person in particular, Jens Schuld from Germany, had bought a taper turning attachment and it had several parts missing, and he requested a general arrangement and some detailed drawings from me, and I was very happy to supply that. But to my great surprise, in exchange for that, he offered me this wonderful collet chuck for the Colchester Student lathe and 3 collets. Also a couple of bearings for the cross slide travel. He'd picked up that I had some problems with those bearings. So thank you very much, Jens, for this wonderful gift. I haven't had a chance to actually use it before because my lathe was in Pakistan and this was in the UK. So now that the lathe has been brought over here, I have the opportunity of installing it. As you can see, the collet chuck is lever operated, and it requires a mechanism on the rear side to an anchor point on the headstock. The headstock has a tapped hole in there, a 1/2 inch UNC, and a machine face, so we can put some kind of anchor in there and make a linkage. We'll go over to the lathe and have a quick look at that. Difficult to get to, but you can see here a hole that's 1/2 inch UNC, and the machine face here, and there's a ring here up close to it. So what we need is some kind of anchor point using that hole. So I ordered online a 1/2 inch UNC bolt by 1 inch long. I did wonder if a socket head cap screw would be better, but the reason I went for this is because the lower profile head of a hexagon bolt will give me a bit more space on top for the linkage. So that was my thinking at the time. But it might make manipulation with the spanner versus an Allen key a bit more challenging. We'll see. I think it will be okay. And it does look as if that space in there was designed to clear a hexagon headed bolt. Now I've got some angle here, and what I'm planning to do, it's actually 1.5 by 1.5 by 1/4 inch thick, so it's nice meaty stuff. So what I want to do is drill a close fitting clearance hole in that, and then I want to profile this to the profile of this and arrange it so the center line of this comes through the center line of the axis of the machine, and that would mean that the linkage is nicely aligned for the collet chuck. So I have my faceplate on the bench so I can easily work on it, and I'm setting it up to cut the 3 inch radius on the bracket. Well, our workpiece is here, but let me explain what everything else is because it looks a bit busy. Next to it I've got this other piece of angle iron, and that's just to provide extra support because clamping it here with one bolt isn't going to be sufficient. It's going to rotate on an intermittent cut. And what we're going to be doing is machining this radius here on the inside. So I produced this GA. This is the annular ring which the clamp faces up against, and this is the 1/2 inch UNC bolt. And you can see here on the end view the strap which attaches to the clamp. So I produced a detailed drawing, and you can see that we need a 3 inch radius on the inside here, and that will be machined here, and then we can get ready for machining. It's taken quite a long time actually to set this up, as you can probably imagine. I'm going to remove these. We no longer need them. And I'll put this in here to provide a bit of extra support. I'm going to add a couple of counterbalance weights here. So we're going to put this one on here and this one on here. So hopefully that should give an approximate counterbalance. So we'll take this over to the lathe now and machine that radius. Just double checking that everything clears. So I put my center in, and I can use a scale to check the radius we're cutting at, and at the moment it looks like we're cutting at around about 1/8 of an inch under the 3-inch mark, so we'll keep going. Okay, we seem to be at 3-inch radius, but what I'm going to do is to take this out and measure the thickness between the edge of the hole and this radius here, because that's the most critical dimension. This radius can be slightly out and still fit, but that's got to be right. We're looking for here for a thickness of 0.127. And we've got 0.13, so that wasn't a bad guess, was it? Okay, so we'll take 3 or 4 thou off that, and then we'll try it. And before I do that, I'm also going to put a chamfer on the rear edge here, so we can clear the remnants of the gasket, which is going to fill up that space. Okay, we will put this internal threading tool in now, and we'll use that to put a rear chamfer in there. I'm just going to touch that up on the grinder. So here we are, here's the finished component. Just give it a deburr, and we'll take the faceplate off, and then we'll see if it fits in. Good, that seems to fit okay. We'll just tighten that up. Now there needs to be a spacer in here which I will fit later, but for the time being I just want to see that the fit between the bolt and this radius here is correct, and that looks fine to me. So this part of the job looks like it's finished. We can move on to the next part, and of course what I was hoping to achieve was this being on the radial center line. And so this needs to be radiused here, and I was going to set this up on my rotary table and mill that, but to be honest with you it's just too complicated. I've got a button here of the right diameter. I've just bolted that through there as a guide, and I will do this by hand. I've just picked up the 3/8 center, and now we're going to drill this out for a 7/16 UNF thread. Off camera, I've added another radius on here, again by hand, because that was by far the quickest option. It really only took about 5 minutes, and it would have taken a good deal longer than that to set it up on a rotary table. And that radius is now finished, as you can see, and it looks good. And I've also added this bush. Now that bush is there to provide some extra height so that the bolt head sits up somewhat. Part of the reason for that is because this isn't flat. Usually on angle iron the inner angles, the inner surfaces are not flat, so that gives a nice seating area for the bolt. But being raised up slightly, it provides just more access for the spanner. You'll probably see that as we assemble it later. What I'm working on now is the screw that goes in here. I've actually enlarged that. Originally it was 3/8, but I've gone to 7/16 UNF, and the screw will tighten up on this with a shoulder here, so that it will provide a clearance between this and the head for the strap. Now I want the strap to be a good fit on the diameter, but I also want it to be constrained between the two faces. Twisting this is going to result in the collet chuck handle flopping around. So if I can keep that fairly tight, it will limit that sort of backlash or flexibility. On the other hand, we don't want it to be too tight, so we're just looking for a nice clearance. So I'll move over to the lathe now and show you the screw, which I've already started to make. So the screw is made from EN8 medium carbon steel, a little bit tougher than simple mild steel. You can tell as you machine it that there's different properties. You see the swarf is much finer. It's just that bit harder. A little more difficult to get a good finish on it, but this is more than adequate. I've already threaded it. This diameter is correct. That's just under 1/2 inch. So when I ream the hole in the strap, I'll have a nice fit on there. So what I'm working on now is the distance between this shoulder and this face, because sandwiched between the bracket and that face will be the strap. The material will be a bit wider than this, but the same thickness, 1/4 inch. So I want to get that to be a nice fit. So a bit of trial and error here. .248. .248. So it looks like we need to, I'm going to aim for 1/4 inch exactly. I'm sure that the cold rolled mild steel will come out slightly under 1/4 inch. So if I go for 1/4 inch here, it should be a good fit. So that means we're going to take 3 thou off this face. So I just noticed that's not running true. Probably using that wrench on there wasn't a good idea. So it's just got slightly moved in the chuck. So what I'm going to do is just true it up again before I take that cut. Okay, time to part off. The last operation on the screw is to cut the screwdriver slot. I've mounted it in the bracket because that's easy to hold on my vertical slide. And incidentally, you're probably wondering why aren't I using the milling machine, which would be more convenient. Well, that's because I haven't yet made a slitting saw arbor for the milling machine, so I don't want to take time out for that now, so I'm just using the lathe. I've used this setup before. So what I'm going to do is measure this diameter, find the radius, and I'm going to use a feeler gauge against the edge of the slitting saw, and I've got a dial indicator down here, and I use that to dial across to the halfway mark. Should be 7/8. It is. So that's 7/8, 0.875, and I've got a 25 thou feeler gauge here, and we'll just bring it up to the edge, zero the dial indicator, and then we'll do the arithmetic and dial across. So I need to come across 0.488. One, 4, 450, 60, 70, 80, 88. And I'll just lock the carriage. I'll just do a visual check from the back to make sure that it looks right. Looks right to me. Right, we'll cut this slot. Now the screw slot, I'll probably just deburr that. So that's part of the assembly finished. Well, when I started this little project, I thought it would only require one video, but I've run out of time and there's quite a lot still to do. So I do hope you'll join me next time.